All right, last lesson of the chapter, 4.4b. And we kind of have 3 parts today. All right, we're going to start with, we're going to take derivatives of logs. Do you think Lindsay is watching? Hi, Lindsay. No?
Hello, hello.
I guess not. Should we teach her wrong stuff? Just kidding. Okay, here we go. Letter A. And then I'll teach the real lesson. Natural log. Let's start with, we're going to do 3 parts today. We'll do natural logs, and then we'll do logs of any base, just like we did. E was our base for exponents, and then any base. And then on the last part, it will do some implicit differentiation. You're like, what is that? Okay, here we go.
Sounds familiar.
First of all, if you have the function y equals the natural log of x, and if you take the derivative of that, the derivative of the natural log of x is simply 1 over x. Now, you can ask for a proof on that. You could probably find one online, or you can just accept it and memorize it.
But why?
But why? Okay, let's do it. I'll show you. Just kidding. No. Okay. All right, but don't forget, most of the time you are going to do chain rule when you do these, okay? So if you're taking the natural log of some function u, what you're really doing to find the derivative is you're doing 1 over u and then times u prime, okay? So let's do some. Number 1. So all of these are just find the derivative. Find the derivative over and over and over. So let's do the natural, y equals the natural log of x to the 4th. Okay? So there's an outer function and there's an inner function. The outer function is the natural log function, and the inner function is the x to the 4th part. Okay? So take the derivative of the outer function first. So it's natural log of stuff. The natural log of something, the derivative of that is 1 over that something. So 1 over x to the 4th. And then times 4x to the 3rd. And then you need to simplify that.
Oh.
Do you remember your exponent rules? I just taught them on Monday in my Algebra 2 class. We have 3 x's up top and 4 on the bottom. And so we end up with 4 over x. Okay, that would be the derivative. Now, let me show you a different way that you can actually do this problem. Do you remember your log properties? What can we do with that 4? Yes, you can bring that 4 down to the front. Do you remember that?
Yeah.
That was my favorite log property. It still is. And then from there, you could actually take the derivative. So the derivative of 4 times natural log of x, 4 is just a constant. So it's going to be 4 times the derivative of natural log of x, which is what? 1 over x. And so you get the same answer by doing it a different way. The more you know. I really like that way better. I don't know. But if you didn't see it, it's fine. Either way. Yeah, me too. All right, number 2. Now I'm going to give you almost the same problem, but it's different. So let's do y equals the natural log of x to the 4th. Okay? This is different than natural log of x to the 4th. You can't bring that 4 down. We're going to take the derivative of this, and there's only one way to do it. Okay? There's an outer function and there's an inner function. Your outer function this time is a power rule of 4, and your inner function is natural log of x. So when you're doing chain rule, you have to do the outer function first, leaving the inside alone, and then take the derivative of the inside. So here we go. We're going to take that 4, and we're going to bring it down to the front, and then subtract 1 off of it. That's the outer function part. That's just the power rule. Times the derivative of the inner function. 1 over x is the derivative of natural log of x. And so you can leave your answer like that if you want to. You can also write 4 natural log cubed of x over x if you want to write it like that. That looks kind of gross. I don't really like that very much, but it's kind of like the sine, you know, like sine squared of x. You can write it like that. And that would be the derivative. All right, let's do a product rule now. Number 3. Y equals e to the x times the natural log of x. Let's find the derivative of that guy. Okay, this is product rule. These are two separate functions. There's no chain rule here, which is kind of nice, but here's one function, that's a. Here's the other function is b. So we're going to do ab prime plus ba prime. You ready? Let's do it. All right, so a is e to the x times b prime is 1 over x plus b is natural log of x times derivative of a is e to the x. And then there's nothing to really simplify here. You might want to rewrite this as e to the x over x plus e to the x natural log of x. That would be perfectly fine to write it like that. No, I mean you could leave it like the other one because there's nothing to simplify. All right, feel pretty good? Yeah, let's do one more. You're like, but we feel good. Too bad. Number 4. Y equals the natural log of the tangent of x. Okay, try this one. You want to do this one on your own or you want me to do it with you? Okay. Ooh, I like that. All right, we have an outer function and an inner function. Our outer function is natural log. So we're going to do 1 over tan x times secant squared x. No. We have to check. So this is secant squared x over tangent x. Can we simplify that?
Probably.
I don't know. Maybe. Let's check. So secant squared x is what? 1 over cosine squared. And tangent is sine over cosine. So we can take that guy on the bottom and flip it. It is the tapestry. So we get 1 over cosine squared x times cosine over sine. And then what happens is one of those will reduce with one of those, and our answer would be 1 over cosine x sine x. And I would be okay with that, but maybe you don't feel that great about it. You might write secant x cosecant x. Remember learning all those properties or identities, I mean? Long time ago. Okay, let's move on, part B. So you felt good up until then. Good. All right, now let's do any base. Any base for log, okay? So let's say we have y equals log base a of x. So not natural log. What's the base of natural log? Do you remember? It's e. If there's no number there, then it's the common log, which is 10. Okay. Y prime is equal to, and here's the derivative. You're going to do 1 over x times the natural log of the base, a.
That's it.
That's it.
Cool.
If you ever forget that, you can always change this to change a base formula. You could do natural log of x over the natural log of a.
Wait, is that easy? It's
Yeah, but I wouldn't do it that way. I would stay with this.
what?
If you ever forget the rule here, you can do.
No, but like it's that simple. If it was like log 3x, it's like 1 over x natural log of 3.
Yeah.
So it's like
Yeah. So you want to do an easy one real quick?
Yeah.
Okay. Number 5. So let's say we have y equals log base 2 of 3x. Let's do a little bit difficult. Not completely easy. Okay. So what you're going to do, this is chain rule. We're going to take the derivative of the outer function, which is log base 2 of stuff. So what you would do is you would do 1 over 3x times the natural log of 2. And then times the derivative of the inner function, which would be 3. and then simplify. I've got a 3 here and a 3 there. And so this is a 1 over x natural log of 2. There it is. Okay. By the way, let me show you this one real quick. If you have y equals log base 2 of 3x, do you remember what you can do here using your log properties? Log base 2 of 3 plus log base 2 of x. Yeah, when it's times, it ends up being addition for your log properties. And this is just a constant. So what's the derivative of log base 2 of 3? It's 0. And then the derivative of log base 2 of x would be 1 over x natural log of 2. It's the same answer. Interesting. 2 different ways, using log properties or not, using chain rule. Okay, let's do another one. Number 6. Nope, new year. Another one. Okay, sure. I just couldn't. Okay, let's do it. Y equals log of sine of 3x. Oh, dang. All right, we're going to find the derivative of this. This is going to be a tough one. This is going to be chain rule twice. Okay, there's an outer function, which is the log base 10. And if you don't like that 10's not written there, you could write that in just to make sure that you'll do that. And then we also have a sine function and a function of 3x. Okay, so there's 3 of them going on here. So let's try it. First of all, start with the log on the outside. So the derivative would be 1 over sine of 3x times the natural log of 10. Okay, that's just the outside part. So it's 1 over log of some stuff, and then don't forget times the natural log of 10. Times, sine of 3x. Oh, you're not to change anything on the inside. So when you do chain rule, you're taking the derivative of this outer part first. You leave the inside completely
the
alone.
Other one, on like when you said log base a of x, it's only x times the natural log of a because it's only x.
Yes, yeah. I probably should have written it as u. I should have done that again. So like if you had y equals log base a of u, and you take the derivative of that, it would be 1 over u natural log of a and then times u prime. So that's what it would be for chain rule. Okay? What are you doing there, Jack?
Slacking.
No, he's watching something. I don't know what he's doing. Okay, here we go. Now, all we did so far was just take the derivative of the log part. Now we have to take the derivative of sine of 3x. So times cosine of 3x. And then finally, what's my last step? Times 3. Okay, let's put this all together. So I've got a cosine of 3x, and I've got a natural log of 10 sine of 3x. You can leave it like that, that's fine. If it's a multiple choice and they don't give you that answer, then it gets a little tricky. They might say 3 over the natural log of 10 times cotangent of 3x. Cosine of 3x over sine of 3x.
Oh, yeah.
Cosine over sine is cotangent. I know. That's why it's so important to know those. Okay, and last part, and then we'll talk about what's going to be on the quiz tomorrow. All right, letter C. Now we're going to do a combination of exponentials and logs together. Okay, we're going to do expos and logs, and you're going to use implicit differentiation. That's when y is mixed in, and you have to do y prime, right? Okay, so here we go. Number, what are we on, 5? 7. Wow, we've done a lot today. I did 23 examples in Algebra 2.
Oh.
Yeah, and they were, yeah. And we're back. Okay, so let's do y equals x to the x. Okay, we haven't done one like this. We've done e to the x and like 3 to the x, but we've never done a variable to the x. So what you want to do with this one is you want to start by taking the log of
x to the x or u to the x?
x to the x, or any variable down here to a variable up there. So what we want to do, yeah. E's not a variable. Oh, u, yeah. We'll stick with x though. All right, so you want to log both sides. That's your first step. Okay, so you get log of y equals log of x to the x, and what do you think I'm going to do? Yes, I'm going to bring it down to the front and multiply it. Ignore this part over here. What happened? Why can't I erase?
What if you just tried using the undo button?
Here, I'll just go in circles. Well, undo. I have to do a whole bunch of undos. Okay, so now we're going to take the derivative of both sides. We're going to use implicit differentiation, okay? So we're going to take the derivative of the log of y. Derivative of log of y is going to be 1 over y. You know what we should have done? Can I go back?
Yeah.
We should have taken the natural log of both sides, because derivative of natural log is way better than regular log, okay? So let's do that. Let me go ahead and go like this and start over. Well, yeah, because we've already done it. Yeah, and the eraser's not working. Okay, so let's take the natural log of both sides. Natural log of y equals x natural log of x. That's going to be so much better, because if you take the log of both sides and you take the derivative, you're going to have to divide by natural log of 10. We don't want to do that. All right, so now let's go from here. What's the derivative of the natural log of y? It's 1 over y times y prime. You okay with that?
Yeah.
Okay. This isn't that bad, though. Equals, and now we're going to do product rule. Okay? So 1 over y is the derivative of the natural log of y, but then we have to do times y prime. So now we have a times b. So a times b prime plus b times a prime. All right, and now we got to fix everything. So you have 1 over y times y prime equals x times 1 over x is 1 plus the natural log of x. And now we have to solve for y prime. So y prime is equal to y times 1 plus the natural log of x. And then finally, go ahead and substitute y back in. What is y in this problem? Look at the first thing you wrote down. Y is x to the x. And that would be your answer. Okay, do you see where I got that? Y? You go all the way back to the original top of the problem, and they tell you what y is right there. All right, we're going to do one more of those, and then we'll find out what's on the test. All right, number 8, last one. You'll have some of these to practice tonight, too. So let's do y equals x to the sine x. So you have to do implicit differentiation when it's a variable raised to a variable. So our first step is to take the natural log of both sides. So the natural log of y equals the natural log of x to the sine x. Bring that sine x down to the front. And then put a little multiply sign right there so that you know to do product rule. Oh, you're back. What have you been doing? Okay, so now, never mind. Nothing. So now let's go ahead and take the derivative of both sides. Okay? So the derivative of natural log of y is 1 over y times y prime equals product rule. A times b prime plus b times a prime. So a, which is sine x, times b prime, 1 over x, plus b, natural log of x, times the derivative of sine x, which is cosine x. You guys are getting really good at derivatives. Do you feel that? No. Okay. Do you feel it's a tingling sensation? You might want to go get that checked out. All right. So y prime, 1 over y times y prime. You get sine x over x plus, it doesn't matter which order you write this in. What do you feel like?
Natural log.
Just leave it, yeah. Natural log x cosine x. And then finally, we need to multiply both sides by y. And you can change it at this point, okay? You have to write all that stuff down. So we're going to multiply both sides by y, and y is x to the sine x. And there's not going to be anything to simplify at the end of these. And then that'll be it. They're not too bad, right? It looks worse than what it is. But there'll be at least 1, maybe 2 on your quiz tomorrow.
How is that multiplied by 1?
Oh, you multiply both sides by y. Right there. And then y is equal to x to the sine x. Yep. So, quiz review. Or basically what's going to be on the quiz. You're only going to have, I think it said test on Canvas. I changed it, I think. It should say quiz, okay? It's only a quiz. It's on 4.3 and 4.4. It's just on what we've learned this week so far. 50? No. Does it say 50?
No, how many points?
Oh, it'll probably be 25 to 30. I know, it's kind of a bigger one. There's a lot of questions. It's a lot, yeah. And by the way, if you have a lot of questions on your homework, you want to come in the morning because we're on assembly schedule tomorrow, and we're not going to have very much time to answer questions in class, okay? So I'm here by 7:40, 7:45. You want to ask some questions if you're missing a bunch. Check your odd answers in the back of your book to make sure. All right, so the first thing you're going to do is I am going to give you 2 problems on the inverse trig functions. 2 on inverse trig. Now, if you are someone who likes to memorize, like Peyton, I think you're going to memorize them, right? Yeah. Go ahead and memorize the formulas. I have no problem with that if you want to do it that way, okay? I can't memorize anything. I don't even know half the people's names in my ham class. And that's no joke. Okay.
You know all of them.
Yes, I know all your names. That's easy. All right, 2 inverse trig functions. So you want to do an example real quick of that?
Yeah.
Okay. So let's do y equals cosine inverse of 3x. And you have to find the derivative of that. Okay? So if you want to memorize the formula that works with this, that's the way I used to do it. But then I couldn't memorize them anymore because I'm getting old. All right, so number 1. What you can do is you can cosine both sides and get cosine of y is equal to 3x. And then you take the derivative using implicit differentiation, and you'll take the derivative of cosine, which is negative sine y times y prime, equals the derivative of 3x, which is 3. So then you would get y prime is, I'll just move the negative to the top with the 3 over sine of y. But then you can't leave that. And I even say answers must be in terms of x. You can't leave sine y. So you're going to go ahead and make a triangle for yourself. And we'll call this angle y over here. And we know that from here, cosine of y equals 3x. So that would be adjacent hypotenuse. And I need to find the sine of y, so I need opposite over hypotenuse. And this would be a squared minus b squared equals c squared. So that would be this side right here. Yeah? I think so. Okay, so then y prime would be negative 3. The sine of y is opposite over hypotenuse. So that would be 1 minus 9x squared. Okay?
Why would it be negative, please? Because of the negative sign?
Negative sign.
Oh, yeah.
Yep, I just moved it to the top. Now, do you want me to teach you the other way, like to memorize a formula?
No.
No.
It's in our notes, so.
Yeah? Does anybody want that? Say yes if you do.
Say what?
Do you want the formulas and try and memorize them and stuff? No.
It's very
Wait,
nice.
is it in the book?
It's, yeah, it's in our
Okay, no,
notes,
there-
too.
Yeah. I don't like them. Okay, so you'll have 2 of those. All right, and they're not too bad. I didn't make them super extra hard. Okay, then you're going to have derivative of expos and logs. And what I did was I combined them together. They're a mix. And you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. 10 of those. Okay? And that's the stuff that we did 2 days ago and today. Exponential rules, don't forget the derivative of e to the x is e to the x, derivative of natural log of x is 1 over x, stuff like that. You'll have products rules, you'll have chain rules, you'll have things that look like you're supposed to do a exponential rule, but it's not. Like for example, you might have something like e to the 7th x squared. And you have to take the derivative of that. That is not product rule, and it's not exponential rules either. This is a power rule. Okay, e to the 7th is a constant. So to take the derivative of this, you bring the 2 down in front, subtract 1 off, and that's it. Okay? If I asked you what the derivative of e to the e is, what's the derivative of that? That's a constant. It's 0. I know. Don't you hate that? E to the x would be e to the x. But e to the e is a constant, so the derivative is 0. They're just tricky, you know? Look at here and say, is that an exponent or not? Or, I'm sorry, a variable or not? It is an exponent for sure. Okay, and then you're going to have 2 implicit differentiations that involves exponentials and logs. It's the ones we just did. Like y equals x to the sine x. Stuff like that. Okay? You'll have 2 of those. Just did them. Yeah, where you take the natural log of both sides. Which one? This one?
Yeah. Oh,
Okay, so if you have a lot of extra questions or you need extra help, please come in the morning.